It's a good one. All right, so guys, today, section 10.3, ellipses. Again, this is a 2-day section, so again, today we're going to hit day 1. Big emphasis is going to be on the physical structure of the ellipse because this is a brand new concept. Brand new in terms of, I mean, yes, it's a conic section, so I guess brand new in terms of conic sections, but again, about a week ago, you had never heard that phrase anyway, so brand new in terms of a mathematical graph or structure. So that's the big difference between parabolas as a conic section versus now today ellipses and then in the future hyperbolas. That the difference is that in previous classes you've learned a lot about parabolas. Ellipses are brand new. Okay, so that's a big part of why we did that ellipse investigation. How did those go overall? Okay, like I said, through doing the investigation, does that mean that you have mastered all things dealing with ellipses? I mean, gosh, I hope so, but that's not the expectation. Okay, I'm hoping that we just started to get familiar with the structure, and you know, we asked some key questions, specific questions that were intended to be leading questions to where by asking this, we get you to look at this part or look at that part or, oh, I'm noticing that this is happening or that's happening. So hopefully we're going to fill in any of the holes or fill in any of the gaps today with the 10.3 day 1 stuff. So the goals that we have in mind, students be able to understand what an ellipse is and all of its physical parts. That's going to be the big part for us today. Hopefully the investigation got this going, but we're going to be defining some of these key parts and then, you know, really honing in on what it is that you're supposed to be looking at or focusing on. Number 2, students be able to find the center, vertices, endpoints, foci, and eccentricity of an ellipse. So our homework today, like this is going to be what we're doing in each one of these. You're also going to be asked to graph. So if you need graph paper, please make sure to grab some on your way out. When that time comes, but again, you'll need some graph paper. That I know that some of you have graph paper, but if you don't, please grab a few sheets. Doesn't take a mathematician to notice that you're going to be asked to identify more stuff with ellipses than you had to with parabolas, right? Again, with the parabola, it's usually identify the vertex, the focus, and the directrix, and then move on. Here we've got center, vertices, endpoints, foci, and eccentricity. The good news is that once you understand your variables, which you're going to have more variables also, again, parabola is all about HK and P. When we get into the ellipses, it's HK, A, B, and C. Once you know those 5 things, then the rest of this is relatively easy. So the majority of our, I don't know, mathematical, energy is going to go into finding HK, A, B, and C. Okay. Again, that what's going to feel like the work that you're doing is identifying those variables. Once we know the variables, if you're understanding the structure, it's just a matter of, oh, well, there's my center point, so I've got to go left this much, right this much. I've got to go up this much, down this much. And you're just plotting the points. So if we do it right, it's going to feel like a whole lot of counting boxes is really what this is going to be. All right, and then goal number 3, students be able to write the equations of ellipses in standard form and graph ellipses. So what that's really getting at is, you know where this is going probably already, that you're going to be given the wrong form of the equation. Can we complete the square, manipulate it to where it looks right, and then we can identify, oh, well, there's H, there's K, there's, again, A and B, and we'll figure out C as we go. All right, so more goals. A lot of goals here in 10.3. We want to learn and understand what an ellipse is and all of its physical parts. We want to learn and understand the different type of ellipses, their standard equations, and how to use them. All right, so the ellipse investigation, we've already collected these. We already talked about them. I don't think we need to go back, but I'll reference these a couple more times. I think we can just skip right over that slide, move on to this one. All right, so if you recall, when we introduced the parabola, and again, that's already a false way of saying it, introduced. You knew what a parabola was when you walked in the door. But when we were looking at a parabola as a conic section as compared to just a quadratic function, we had a different way of defining. We said, yeah, we're creating that collection of points that are equidistant to a focus and a directrix. That's what puts a point on a parabola. So in a very similar way, we're going to say that an ellipse is going to be the set of all points in a plane whose distances from 2 fixed points, called the foci, in the plane have a constant sum. All right, so first thing that jumps out, we have a new word here. It's not really a new word, but it's a new word. to this point, we've talked about a focus. This is the focal point. With an ellipse, you have two. You have two focuses, which isn't a word, so foci is the plural form of focus. So we're going to have a focus here, we're going to have a focus here. Together, those are your foci. That's how we would say that. All right? So what we're claiming is that this ellipse, this oval shape, or whatever we want to call it, this point that lives on the edge of the ellipse, and it could be anywhere on the edge of the ellipse, what we're saying is that any of these points, if you were to find the distance to one focus and the distance to the other focus and add them together, okay, so that's what it's saying here. That's our first distance and that's our second distance. That's going to create what we call a constant sum. Okay? Again, I'm going to just make up and use really simple numbers here. If we add these together and we got 5, what we're saying is that if you move that point over here and you found this distance, that distance, it's still going to be 5. If you moved it, moving all sorts of stuff everywhere here. Let me get some of these things out of the way. Oh, now it doesn't want to play nice. Okay, all right, let's see. Okay, so if we moved it down here, those distances, add them together, you're still going to get 5. Move it down here, you're going to get 5. Move it over here, you guys get the point? That no matter what, that distance, any point that's on the physically on the ellipse, okay, if you were to measure to the first focus, measure to the second focus, add them together, you're going to get the same number over and over and over and over. Okay, it's what we call a constant sum. All right? So, what questions could I answer so far about the foci, about, I'm not trying to do that, about this idea of a constant sum, physically where this structure comes from? So far, so good? All right, so the other thing that we want to talk about here is that the line through the foci is what we call the focal axis. Now, I would encourage you to write major axis next to it. Now, we're gonna define major axis here in a couple slides. I just don't want you to have multiple terms floating around. Major axis is what we're really going to call it. So, again, we haven't defined all of these other pieces that we're drawing up there, but as we look at this, we said that we have a focus here and we have a focus there. What we're saying is that if you were to draw a line through the foci, if we call that the focal axis, because if it's horizontal, your ellipse is horizontal. If it's vertical, your ellipse is going to be vertical. So that's the only reason why this concept exists. So the line through is what they call the focal axis. What we're going to do is that if we were to look at the chord that goes from vertex to vertex, that's what we call the major axis. So we're not really going to care about the line that extends to infinity. We're going to care about from vertex to vertex, and we're going to call that here in a slide or two. We're going to call that the major axis. So that's why I want you to write that up there, just so you're aware that, yeah, we kind of have two different words for the same thing, or two different terms for the same thing. I just don't want to create confusion. This is probably the last time we're going to call it the focal axis. We're going to move on to the major axis from here on out. Okay? Questions so far? Okay. So a few terms that we want you to know. I've already kind of thrown them in there, sprinkled them in as we go here, but vertices. If you were to draw that line, again, what we just said to be the focal axis, if you were to draw that line through the foci, you're going to run into the ellipse, okay? Those points that are on the ellipse, those are your vertices. So we have a vertex here, we have a vertex there. So long as this is the axis that's going through the foci. Again, we didn't plot them over here, but you probably have a focus here, you probably have a focus there. That would be it. Okay? Which is going to lead us to the major axis. This is where it all hopefully starts to come together. The major axis, that's going to be the chord that's containing the vertices. So again, when we draw this chord in, we connect the vertices. The vertices are just the endpoints of your major axis. Okay? Now that major axis, notice what it goes through. We say it goes from vertex to vertex, but it goes through the foci. Also goes through the center point, which we haven't defined yet, but you can probably figure out with relative ease that everything is sort of built around the center point. Okay? If you had to guess right now, thinking about this in terms of variables, what do you suppose the center point is? Oh, it might be in a coordinate axis. It could be at the origin for sure. but the center point is going to be located at HK. All right, we're going to define all this here. We have all this documented here in a couple slides. But if you're, playing along here, so to speak, the center of a circle was at HK. The vertex of the parabola was at HK. The center of the ellipse is at HK. We haven't even talked about it yet, but when we get into hyperbolas, the center of the hyperbola, it's going to be at HK. So basically, HK is like that most important point when we're talking about the conic section. Okay, so that's going to continue not just today, but into the future. All right, so the center point, again, we can, and we will be a little bit more specific, but the distance from the center to the first vertex is going to be the same as the distance from center to the other vertex. Same with the foci. The center is going to be the midpoint between the foci. The center is going to be the midpoint between your vertices. All right, so are we all feeling pretty good about that major axis, the thing that we've drawn in both of these ellipses in red? Horizontal, so that's why we would call these horizontal ellipses. Now, the reason why I want to be, I don't know, identifying this in terms of major axis versus focal axis is that now we also have a minor axis, okay? It's a whole lot easier to me, in my mind, even before we define this, which one do you think is bigger, the major axis or the minor axis? Major is going to be bigger, we know that. If we define them as focal axis versus minor axis, do we automatically know which one's larger? I mean, not necessarily, but I mean, when we call one major, one minor, we know which one's bigger. And that's going to tell us the difference to where if you're comparing, how do you know which one's the major, which one's the minor? The bigger one's the major axis. So again, the minor axis, by the way, this is going to be the chord that's perpendicular to the major axis at the center. So if here the major axis in red is drawn horizontally, if I were to draw now a vertical line through the center point, it's perpendicular, that's going to be what we call the minor axis. Now, I know we're about a slide away here, but the minor axis, this is going to intercept and create points on the ellipse, just like the major axis led to the vertices. We just don't have a fancy name for them, so we literally call them the endpoints. So if you think back to your goals, you're asked to find the vertices, the endpoints. That's what they're talking about. The foci, the eccentricity, I missed the center. So again, we still have to talk about the eccentricity, but when we talk about the endpoints, that's what we're talking about. The endpoints are the endpoints of the minor axis. The vertices are the endpoints of the major axis. Okay? How do we feel about these terms so far? Good? Not good? Somewhere in the middle? All right, now, not that I want to say, oh, this slide is more important than a previous slide or the next slide. I don't know about any of that, but I feel really confident when I say that if you really understand the parts of this slide, all the information on this slide, I think that's going to lead to a lot of success with section 10.3. So I don't know if you need to take out your highlighter, you need to star this slide or whatever it is, but if you find yourself struggling on tonight's homework or tomorrow's homework, I'll bet that if you could kind of anchor back to this particular slide, that's going to probably set you straight. Okay? So this is where we're going to start to create the link, as I said at the beginning, that we really need to figure out those 5 variables. We need HK, A, B, and C. Hopefully HK is already taken care of. If we know the center point, we know HK. Okay? Just like with circles, just like with parabolas. Okay? But now that we're talking about how do we find A, B, and C, well, it's kind of like on day 1 of parabolas. We didn't know what P was until we studied it a little bit. Currently, we don't know what A, B, and C represent. Okay, so that's what this particular slide is trying to link to. So we say that with ellipses, there are specific variables attached to specific measurements. So starting off with, hopefully we're starting to feel more confident with the structure. We have the center point, you have the foci, we have the vertices. Didn't write it in, but we have the endpoints up here. So there's an endpoint, there's another endpoint. So what we're saying is that every time, no matter what, that the distance from the center to a vertex, doesn't matter if we went to the right or to the left, because they're going to be the same. The distance from the center to the vertex is A. Every time. How do we feel about that first one? Okay? Second one, the center to an endpoint is B. Again, doesn't matter which endpoint, it's going to be the same. The center is It's not accidentally called the center. It's very intentionally called the center because it is the midpoint. It's the center of the minor axis. It's the center of the major axis. Okay, same thing.